Hi, this is Nathan Tintle. In this learning goal video, we will discuss when a theory-based approach is valid for comparing paired means. We will use the M&M's example to talk about this learning goal. In the M&M's data set, there are 17 different students who take M&M's from both a large bowl and a small bowl. Because the students took M&M's from both bowls, the design is paired, and the validity conditions are different for paired data than they are for independent data. When you have paired data, you're really looking at the difference scores within each pair. So for each of the 17 students, you're going to take the number of M&Ms that they took out of the small bowl and subtract the number of M&Ms that they took out of the large bowl, getting a single number, the difference score for each student. You now have 17 difference scores, and you can see them on the dot plot. Here's what the validity conditions are. When there are at least 20 different scores, and the distribution of different scores is not strongly skewed, the theory-based test and confidence interval will work. If there are less than 20 different scores, that's the case we're in now, the distribution of different scores should be symmetric. If you see this dot plot we have here, the data looks pretty symmetric, and so the conditions are met. Even though our sample size is small, distribution is fairly symmetric, so the theory-based test is appropriate here. A couple of words of caution. The sample size we're looking at, when we say at least 20 or less than 20, is the number of pairs. And when we talk about symmetry and skew, we're talking about it on the difference scores. Final note, those conditions for the paired difference in means are equivalent to a one-sample t-test, a test of a single mean, because that's what we're actually doing. A one-sample t-test is the same as a paired t-test, that is, a comparison of two paired group means.